Jesse, can I just quickly ask before we get cracking, how were you triggering your cancellation that was causing the hang?
Yeah, I was just hitting Control C, like right as soon as detect starts. And
So
like
just
I saw the word
visually
detect. Yeah,
observing it.
just visually. Yeah.
Yeah.
On my Mac, I had it seem to happen like most of the time. But on Windows today, it happened the first time. I was like, oh, I can reproduce, and then I haven't been able to do it again since then.
Yeah, I wonder when you say that, like the visual bit gives rise to there being like any number of things happening in between the start of detect and the finish of detect, and whether in our efforts to reproduce we're just facing timing issues identifying exactly where it is.
That's
I
kind
was,
of
go-
what I figured. Yeah.
I was gonna say a hard issue. A good issue that I had reproducing it was that I found it really difficult to stop it during detect because it was so fast.
Yeah, it's right when the detect phase shows up, but like before you see any, because obviously like the detect logs are super fast, because detect is fast. So it's like right before, the only time it's ever frozen was before the any logs, but after the detecting phase log. So it's probably a trusted builder thing too, because it was a trusted builder. I don't know if that changes anything.
Right. Well, I think I suppose that might be worth investigating because there is because we trust by default the suggested builders, but the actual builder you used in your example was not the
Yeah.
default Heroku build pack. So
Yeah. Actually, yeah,
that's
you're right.
that's another avenue to check. Cool.
Should we go ahead and get started? All right, don't forget to sign into the document. Looks like there's definitely a few people short there. Do we have any new faces? Anybody that wants to introduce themselves or maybe doesn't come frequently? Doesn't look like it. All right, release planning.
We've got a few updates on the platform side. I think David's been working on getting the Tekton tasks updated. We now have 2 tasks that was merged in, I believe, yesterday. And they are now versioned with 01, so 0.1. And we're trying to figure out still the strategy for how the versioning will work there. But overall, we now have the build packs phases, which does the individual phases in Tekton, and then the build packs, which uses Creator. And that'll be out there. I believe Natalie's working on a separate update to the phases, which has already been PR'd. And I'm assuming at that point we might update it to 0.2. But again, discussion still to be had there. That's it on anything that I'm aware of.
Still working on Lifecycle 09, hoping to get out in the next couple weeks. Merging the Symlink fixes in from 0.8.1 ended up being a bit more of a debacle than I was expecting because Windows Symlinks added their own wrinkle. So the release is, I think last week I said 2 to 3 weeks. I'm still going to say 2 to 3 weeks instead of 1 to 2 at this point because of the added time from dealing with that.
All right, cool. Move on to our C review. Top of the list is project descriptor flexibility. I think that was just opened a little while ago. So take a look at it. Layer origin metadata is in draft. PEC subcommands, is this on the list for discussion today?
It's not. I haven't had a chance to review it recently, so I don't know what the state of the world there is.
Yeah, I think I looked at it yesterday. There were just a couple open questions, so looks like it's moving along. Multi-API lifecycle descriptor.
I made 2 changes to this. One is to make experimental, moving everything to being list instead of doing min-max syntax, because Stephen rightly pointed out that post 1.0 that makes more sense. It's included, deprecated, in supported. So supported is a superset of deprecated and non-deprecated APIs. And I allowed for multiple experimentals just for, doesn't seem to be any reason not to allow it, even if we only think we're going to use one realistically. So I think we are almost at a full slate of approvals here. And those who have not approved, please take a look, or those who have approved pre those changes, make sure you're still comfortable with it.
Cool. Experimental features. This is mine. Just haven't had time to bring it up for discussion. It's also not urgent, so I guess take a look if you have a chance. Application mixins we'll talk about today. Inline build packs I thought was FCP, but in any case, I think this has all the votes. Come on, little guy. There you go. Yeah, so we'll move this to FCP. Read-write platform volume mount. I don't think Ben's here today.
I know he mentioned he wanted to take another look at it, and he hasn't had time to review it. That's what I last heard.
Oh yeah, I think that was Terrence's last comment. Yeah.
It seems like it does have enough approvals for FCP, or it did a while ago. But yeah, we should check in with Ben.
Okay. Offline build packages.
Yeah, I just pushed up a new version of this that has a lot of changes.
Cool.
So happy to talk about that more later on in this meeting if we have time. But...
Cool. Yeah, definitely put it on the agenda.
Okay.
We got 2 that are in final comment period, so I think these will move to closed, or finalized. But this one has an X. Is that just Ben's review?
It's DCO, I think.
Okay. Yeah. All right, we might need to
Nudge him.
nudge on that. This is, I think, in draft, but it's going to go away. It's also going to go away. And image exposes metadata for all layers.
I think that's being replaced by the new draft for layer origin metadata. So maybe we can move this to a draft as well.
Should I do that?
It's over on the right underneath the approvers, the little tiny,
Tiny.
This was opened by Paul. Should we ask him before we?
Oh, sorry.
I can check in. I think I can check in and do it later. But I know that he wants to replace this with the draft at the top, layer origin metadata. So I think he'll be okay with that change.
Oh, yeah. I thought this was open. That's why I went ahead and did it. I'll let him know that I am a jerk. All right, cool.
Is the application mixins that's going to replace that's going to encompass the CA certs as well?
That's the idea. I think I know Ben would say that there's enough urgency for the CA certs problem that we might want to do something experimental that doesn't use anything that's spec'd. But my proposal for application mixins would be able to accommodate CA certs. Yeah.
Okay.
Actually, I think that's the first thing on the list. This shouldn't take long. I just wanted to let you know about my updates. Let me share this again. So after the last time we discussed this, I made some significant changes to the CA cert example to have the 2 build pack idea that we were using, where like a regular build pack provides a cert, or well, it's kind of weird. It's like it requires a cert and then the stack pack provides it by reading the actual cert contents from the build plan and whatever. So take a look at that. I think there's some stuff in here that if we wanted to, like, we probably don't need the provides here and the mix in here. So we could make some choices that made it a little bit cleaner, but that definitely would work. The outstanding question I have about this is still the pattern matching. I know we talked about regexes, like how do you know when it's a regex versus an exact string that you want to match? But I think the proposal as it is needs some concept of an apt build pack that can provide an arbitrary list of mixins without specifying what they are. So I haven't had time to, well, no, I have had time. I just haven't come up with a solution to that. So it's something I'm still thinking about.
I have a quick proposal for a solution. I was thinking about this over the weekend. You could do mixins equal and then a list of exact mixins, or you could do mixins dash match equal and then a list of regexes and just keep them in a separate
key.
list.
Yeah. I like that better than we also talked about having types, like making type a first class thing on mixin, and I kind of wanted to avoid that. So I think I'd probably favor that.
So one thing I was thinking is these mixins ship on the stack, right? And stack authors define what a mixin means. Like, do we actually, maybe there should just be one mixin stack pack and you just assume that it can provide any mixin, and if it can't, you could fail. But eventually it would provide all of them because, the stack author is defining the mixin, and then they should update the mixin stack pack to be able to install anything that's defined.
But there could be multiple stack packs, right? You're saying to move away from that?
We don't actually have a case for a stack pack running without any mixin. Like a mixin is sort of like, we've talked about that, but there's not a good example of like something that would trigger it otherwise. So I think that's really interesting, Emily.
I sort of miss the it's going to be controversial. The sort of the stack capabilities way of doing this. I know we've like migrated back towards a lot of things like that, but I could imagine like if a stack advertises 2 capabilities, one is certs and one is mixins, then you expect to have 2 stack packs, one that does certs and one that does mixins. And then the way when people ask for one of those things, we just invoke that build pack without doing sort of the build plan matching at all. But I know that is sort of optimized for this case and has problems when we talk about I feel like even in the detect case, though, you could still have a build pack ask for mixins and just know that you can give it to the stack pack based on the fact that there is a mixin stack pack.
I think in that case, it would be the stack pack, right? Like not necessarily the mixin stack pack. It's just every stack can have a stack pack, a singular.
But
Right.
I think certs actually make sense as a different case, right? And then that would detect based on certs in the platform directory, like we were talking about the last working group. And it doesn't use the concept of mixins at all.
I'm not sure I understand the proposed change. So like what we're talking about right now is a regular build pack, non-stack pack build pack can require mixins in the build plan, and because those mixins are part of a set that's so large that nothing could ever enumerate them, in the case of the app packages, it'd be like it's megabytes of package names probably. They're passed to the stack pack, or like they're passed. The ones that are acquired are filtered by the ones on the stack, and the remaining ones are passed to the stack pack that match that stack pack, and then the remaining ones after that are patched to the next stack pack, etc. Right? Something like that. What's the benefit of going down to one stack pack? Maybe I just don't understand.
I think sort of pushing matching into the build plan makes it more complicated, and I don't actually see a case where you want to divide the mixin installation across multiple stack packs anyways.
But you need to divide it between the stack and the stack pack, right? Because the stack can provide some of them. So if you requested Python and Ruby, and the Ruby's on the stack, but Python's not, you would need to filter that. The lifecycle has to filter that by the stack before providing the remaining mixins.
So it filters out everything that's already in the stack and gives the rest of the stuff to the mixin stack pack. Done. There's no like provide, require, match. It's just this one gets mixins, and you assume it can do all of them. As we implement it, there might be a time where it fails if it can't do all of them, but eventually it probably should. So as we define new mixins, we support it in the mixin stack pack.
And you're just saying that way you don't have to have that filter, right? It's like trying to reduce the complexity.
Yeah, and make it work across stacks that aren't bionic in a straightforward way, no matter how the mixins are defined. In some ways it makes sense. So like the stack maintainer defines the definition of a mixin, and then it also provides a thing that can install whatever it's defined.
But you lose the modularity that way, right?
Yes, but I think...
Yeah, I'm not sure what the value of the modularity is, though.
Yeah.
I like the idea of, if you have, starting with a stack image, you can layer on modular pieces that sort of dynamically make changes to the base image. Like if you have if you're a large enterprise and you want to have a special build pack you distribute everywhere that installs your particular CA certs, right? Then, you could add that to your base images and use that to fan out the logic, right?
I'm not saying there can't be multiple stack packs. But I think they have types, basically.
Yeah, like that one you described, Stephen, would just run, right? It would just I guess I could see a case where it had some kind of...
It's like, what if you want to provide a change to the base image that maybe is mandatory, but maybe it could be requested by the app through a build plan, build pack, or could be requested by a custom user's build pack, right? I like how we've interfaced this into mixins and into the build plan system. Like having to put the whole contents of the cert there feels a little weird, maybe, but there are ways around that. And when we decouple the build materials from the build plan, I think it'll clear up some of that too.
I really liked what I thought we had sort of landed on last week, which is put the certs in the platform directory. So that part doesn't have to go through the build plan at all. Because then anyone can install any certs without using the build plan.
I think you could do that here too, like regardless of what the example is. Yeah.
Yeah, I feel like this is just an example of one way we would do it. So I think what you're suggesting is totally fine too.
Like, because we've tied this into mixins, like I feel like what you're talking about with arbitrary changes in modularity gets into the broader vision of root build packs, right? But I don't think we want if we're making this specific to mixins, I don't think we want people making custom definitions of mixins, because we've said it sort of has to be a stack author who's defining what a mixin is, and then this is also shipping on the stack image.
To me, the difference, like, a stack author should define what a mixin is, but a stack author shouldn't be the only person that's allowed to create stack packs for a stack. Because like I think the problem is this word stack author is confusing. It's like there's the person who defines the stack ID, and then there's the person who's distributing stack images that uses that stack ID. There's one person who defines the stack ID, but there's infinite number of people who, like as a project, we've defined IO build pack stacks Bionic, right? And what mixins mean for that. But there's an infinite number of people who might distribute IO build pack stacks Bionic stacks with different sets of stack packs that add that functionality. And so I don't view it like this is a one to, you're the person who's maintaining the stack image, so you can just put all that logic in your one stack pack. I think in many cases, people might not want any stack packs, or might want, a number of them that make different changes to the base image. And the thing that differentiates them from root build packs for me is root build packs break rebasing, essentially, because you can't make guarantees anymore when you can do whatever you want. That's there are additional restrictions for stack packs because they have to have this, obey this ABI compatibility contract, and they don't let you do everything, right? And they have to run using the mixin system that's used to define what that ABI compatibility contract is. But they're not, intrinsically coupled to the person who defined the stack ID. They just, are distributed by people who distribute stack images.
Yeah, I think just piggybacking off what Steven said, I just think of the conversation that when the Cigna folks came here, I think that's a good example of we've defined that stack ID and they're happy to move over to using it. But they want to have a set of automated kind of, I would imagine, stack packs that help them kind of not have that, I forget what they called their Rust binary that did the signification of stuff, but I can imagine them wanting to convert all those things into stack packs that will allow them to have rebase that could basically automate all those things in a kind of reasonable way. Yeah, where they have no relation to us in that sense of the people who define what stacks were.
Yeah, it was like 03 or it was some chemistry thing.
I guess I'm not arguing that there shouldn't be multiple stack packs. But I have trouble imagining why I want multiple stack packs that all use mixins, right?
Look, you can have so here's a more practical example maybe. Say you have a stack pack that just installs, Bionic packages from official repos, right? But on top of that, you want to add support for installing from 2 different other PPAs. You create a stack pack for each of the PPAs that pulls packages from the PPAs instead. And then when build packs require those packages, the ones that, don't have whatever the PPA special prefixes go to the, regular, generic Bionic packages thing, and the PPA specific ones go to the build packs to install the PPA packages.
But wouldn't those mixins not actually be allowable mixins on the Bionic stack, by the way we've defined it?
We have concepts of sets and things like that. We can, as those use cases come up, right, we can define additional mixins. All right, here's a non-PPA.
But then as we define it, can't we just add to the one mixin thing the installation of it, right? I don't know. Because we're not letting people define their own mixins on the fly, I don't know why they'd want to add their own mixin installers on the fly. Does that make sense? Or if they're defining their own, they're sort of on the hook for all of it.
I'd say the right thing there is to allow more custom mixin definitions, right? Allow custom sets and things like that, as opposed to saying that everybody can only use this one particular set of logic, right? Here's an example without PPAs. Say instead of one apt, generic apt stack pack, you only wanted stack packs that install specific subsets of packages that are allowed in your organization from upstream, right? So you'd want to filter out and there could be different modular pieces of functionality to install the different package sets. This way you could require all of those, and the right ones would make it to the right build packs.
I'm not totally convinced, but I feel like I've derailed the conversation enough.
I like the delegation functionality. It's defined. We can talk more on GitHub.
I definitely was happy with the.
I definitely see the value.
Sorry, you want to go ahead, Javier?
No, go ahead.
I was just saying I was really happy with this build pack, stack pack division, where there's like a generic provider of CA certs, and then a user space build pack that, you know, in here I'm just including the content, but like I was saying, it could be a path to the platform or something. There's a lot of different mechanisms, but this felt a lot better to me than the type construct that I was trying to introduce. So
I like doing the CA search in the platform dir, but at that point, I don't know why you actually need to require or provide it at all. Like you can just install it if it's there, right?
Yeah, sure. I mean, I think there's I almost feel like that's a separate discussion about how we actually implement that. And like what I'm trying to illustrate here is are we giving that stack pack or build pack author the power, the capabilities they need in order to implement something like that? We don't have to make a hard and fast decision about, or it doesn't even have to be the same, right? Like the Heroku 18 stack could have its own weird mechanism for providing certs if we wanted to.
I think the only thing that's making me hold off on approving is the bin detect on the stack pack being able to do a dynamic provide. We talked about if it's encoded in build pack toml, then we can pre-validate before we construct things. Is there a reason that was added in? Is there some controversy about that?
Yeah, I mean, I definitely feel like in this example, having the mix in here and the provides here is at a minimum redundant. Are you suggesting that there shouldn't be a detect at all, or that it shouldn't be able to have a dynamic build plan entry?
It's less that I'm saying I would outright reject anything that had a detect on the stack pack. I think I could be convinced that as long as you have the ability to define it statically, and so the validation could happen ahead of time, that we could allow the dynamic validation. We just hadn't discussed it before. And I was wondering if one was supposed to go away, or, you know, why it showed up again.
So the reason I have this here is because I was playing around with this in the current life cycle, and I was just running the stack pack as a regular build pack and pretending it was a stack pack or whatever. So in order to satisfy the requires, I had to provide it. But I do want, like, that's what I'm saying, this is redundant. Like, I want a way for like this in the stack pack to satisfy the request down here. And maybe that means introducing mixins, required mixins to the build plan. I'm not really sure about that, but I definitely, I think I'm agreeing with you basically.
Well, if we took the bin detect out of the stack pack for now and decided that we needed to add the dynamic functionality back in later, I wouldn't be opposed to that, but it'd be easier for me to approve with, like, this is where the provide comes from. It's static. It can be on that build package, so you can pre-validate and that. But either way, or like, if you wanted to keep it in and just explain that we should allow the dynamic ones too, that'd be okay. I think McNew might come back and have, you know, some questions about that, because he was planning on being able to validate it ahead of time.
Yeah.
Well, they could still be what is it, like dynamic, but at the mix-in level dynamic, right? So like it's ultimately you could have both. I'm not really saying that I like it, but you could see that the mix-in itself could use pattern matching, right, for the static validation aspect of it. But then the more specific in the detect, be more specific to what the actual concrete dependency is.
But you shouldn't have to, because like the app build pack can provide, 200,000 packages, right? And so it wouldn't output during detect before it gets the require. Here are the 200,000 packages I install. So in the app build pack case, I would say you'd be outputting the pattern in both cases, or if you couldn't use the pattern in the dynamic case, then you wouldn't be outputting a pattern there. Also, given that I don't think you have access to the appter during detect, I'm not sure I see the functionality.
Yeah, that's true.
Okay, so I'm gonna revise this to have like a first class pattern versus list of explicit strings in the build pack toml. That seems pretty straightforward. And I'm gonna think some more about bin detect. I feel like if it isn't sitting well for me either. So I think I'm with you, Stephen. I want to figure that out a little bit. I don't know. I don't know what direction I'll go, but I want to think about it some more.
Sounds good.
Anything else that I should be thinking about as I rework it? Anybody can think of?
I'm eager to approve this and get it forward. So let me know if there are things I can do to help make that happen. I think it solves a lot of problems. I'm excited about what we've kind of coalesced on too.
Cool. All right, we should move on to the offline build packages. Who wants to lead that?
That is me.
Cool, go for it.
All right. So I guess, can everyone see this?
That's great.
Nice. So it's been quite a long time since the original version of this landed. Do you think it would be helpful for me to just kind of walk through this a little bit again? Refresh people's memory.
That'd probably be a good idea.
Okay, sweet. So kind of starting from the top, kind of what this RFC is doing is pulling out build pack dependencies out of the build pack archive. And there's some benefits we can get from this, namely space optimizations and this kind of one-to-one correspondence between ID and version from the build pack author's perspective. I know there was some talk about this point in particular in the last revision, but I think that there's like a little more context here that'll make it clear. So this is just an example of kind of a current generation offline build pack where all of the dependencies are actually shoved inside of the build pack archive. And we just kind of want to pull this out, make these first class citizens so that the lifecycle can interact with them and kind of like decouple this idea of the build pack bits and the dependency bits. And so how this kind of works is that we are going to modify the package toml format to have this new field for offline dependencies. We can specify where to download these from, and this ID and version combination, which will be used as kind of a key for build packs to look up dependencies that they would want to use during an offline installation. So if we run the package build pack command, we're going to get an OCI format. It's going to have these build pack layers. It's going to have some dependency layers. Awesome. And what this will look like when it's actually all these layers are splatted out. It's going to be, we have this new deps directory that sits adjacent to the build packs directory. And this is going to have all of your dependencies that say the Ruby build pack will install. So we have a couple versions of Ruby and a version of Bundler. And so when a build pack is installing, or when a build pack is being run in this offline mode, what we're going to be able to do is we're going to have to provide the build pack a little bit of additional information, namely around what this ID field is, right? It's going to select a version that it wants to install, and it can kind of like use this information to figure out exactly where on the file system it should be looking for these offline dependencies. And we can kind of, there's like an additional environment variable that we can provide. It's called CMB deps, and it's just going to basically give us CMB/deps. So at build time, you can use this, concatenate it with your build pack ID, the version you select, check if this file path exists. If it does, then your build pack can like do a little bit of additional logic to do an offline build. So in the last iteration of this, there was like a little bit of discussion about why we want to use this combination as opposed to like a hash. And there's a couple dependencies. One of them is this SDCV tool, which both contain like a binary and static data. It requires an absolute path when you build it. So in order to have the ability to build this dependency, put it in a build pack, and have all of the information below this deps ID directory, you need to be able to figure that stuff out beforehand. So any sort of hashing function isn't quite going to work for us. I guess one of the kind of side effects of doing this is we get offline meta build packages for free. As long as all the implementation build packages are packaged up correctly, your overall build pack execution build will just run completely offline. And so this kind of outlines some of the label changes that we're going to need to have so that one of these offline build packages can identify the different archives that it actually wants to splat out on the file system. And so we're just going to add an array. It's going to have a SHA that points to each of these dependency layers. Terrence, I think you brought up some points around layer ordering so that builds would be reproducible in the last version of this. And this just outlines like a lexicographic ordering by diff ID so that every time you build one of these build packages, it looks about the same. It's reproducible. Okay, and I guess this also walks through an example of what happens exactly during build pack execution offline and how this relates to online execution. And it's basically, again, you're just going to check and see if this path exists. If it does, you can do an offline build. If it does not, then your build pack is responsible for some additional behavior. Yeah, I guess that is pretty much it. This is like a long example I could step through, but yeah. I guess questions, concerns on this, or I figure I should probably let people take some time and read this since it's quite long.
So the ID is the ID of the build pack, right? Cloud build pack?
So no, the ID is the
name of the
ID version that you're going to specify.
Okay.
Yeah.
The dependency.
And yeah, there's kind of these two things are going to have to be globally unique as well. So if two build packs try and overwrite same ID version combination, your build should just fail. There's something that's gone wrong.
And that's why you namespace with Paketo, because Paketo is going to, in theory, share the same set of global stuff across all of its build packs.
Yeah.
The theory there.
That's also why the directories for dependencies aren't namespaced by build pack, because if two build packs use the same dependency, like the layers should have the same SHA regardless.
So am I correct in assuming here that now something like bundler artifact.tgz, right now when we have a dependency like this is usually just containing bundler, for example, but now all these artifacts would be layers. Like even before we've packaged them into a build pack, I'm assuming to be able to do this, the URI to the bundler artifact that we're pointing at in the offline dependency sort of has to be contain a layer object.
So I don't think it does. I think that part of this is you should be able to put any artifact you want here, and what's going to interact with it is your build pack. And the only way it's going to interact with it is by saying, okay, is there something here? And then it's really left up to the build pack to figure out, okay, this dependency was packaged with me. I should know what format it's in. I can decide to behave accordingly.
So in the dependencies in the image, we'll just take the exact contents of this and put them in a directory here. So we'll assume that like whatever's in the TGZ should then go under that directory heading.
Yeah.
So when you say the contents of the TGZ, are we talking about the TGZ itself or the contents inside of there? Like for this layer, right? Because the layer is on a tar format. So is the tar going to contain the TGZ or the TGZ contents? I would assume it's the former, right? It would just be the TGZ itself.
Yep.
Okay.
The TGZ will be unpacked into that directory. Like TGZ will be rooted at 123, right? Be unpacked into that directory so that it doesn't end up double compressed, right? Because the layer blobs are TGZs in the registry, not tars.
Well, that's what I was asking, whether or not they're double compressed or not. It sounded like I was thinking that it was going to be double compressed.
It's not double compressed. It's the TGZ from the URI is expanded into 123, right? So then it's repackaged up as a layer along with the contents of that metadata section under offline dependencies would be put in the TOML file. So you end up with a layer with no tars or TGZs inside of it, you know, for sure, right? Or like no tars or TGZs inside of it unless you had a TGZ
Unless
inside
you
of
had
the
your way
original
to put it
TGZ.
in.
Right.
Yeah.
Exactly.
So it means all the URIs have to be URIs to TGZs. They
Yeah, I was
can't
going to
be
say, what about
zip
other
files or
formats
something.
or jars and stuff like that?
The URI there could be a local path to a directory too. It's just like where to get the thing that goes inside of the 123 directory. Could support zip. It could support, you know.
Well, I
One
think
thing I
that's where it
was-
gets confusing is whether or not it's expanded or not based on the type of URI. I'm still questioning that.
I would say always expand. Like you could support these formats. If you wanted to say this gets plopped inside of there without any decompression, we could have another key for it or something.
Yeah, I was going to ask a question very related to this is like, what is the shape of an offline dependency? And it sounds like it's kind of not defined.
Yeah. I don't think it like should be defined.
Yeah, so like those TGZs are not layers. They're just things that are going to get put into a layer.
Yeah. I think it'd be like equally valid to just be like, all right, this is always just going to be a path to an uncompressed thing. But it does mean that there's a little bit more work that Pack has to do. It's going to take on the work of figuring out what the extension is.
I don't have a strong feeling about how that should work. I do. This is very bike sheddy, but I think dependency is the wrong word because in the other section of package TOML, a dependency is a build pack. Yeah, and that's like it's kind of like when I first read through this, it was confusing to me. I was expecting those to be images and then they're not. And so I wonder if there's like
Assets,
offline.
maybe?
Yeah, I was thinking
Yeah.
assets or packages or something like that.
I think offline dependencies is very specific to one use case, and this could be used
Yeah.
for a lot of other things besides offline build packs.
Yeah, I vote assets as well. Packages is two in the domain where
Yep.
it can be confusing as
I
well.
like assets. Yeah.
One thing I have wanted in the past before is to be able to take an online builder and make it an offline builder, sort of without having to repackage each leaf build pack and then repackage the meta build pack and then repackage the builder. I'm wondering if like in the online case we're preserving URIs in metadata, like we would later have all the information we would need to take an image and just make an offline version of it, which would be a very convenient thing to do.
Like at the lifecycle level, Emily?
At the
Where-
platform level, I don't think the lifecycle can really do this. But if you could say pack builder offline and give it an online builder and then spit out a offline image, that'd be very convenient. Or like at the platform level, you could even, add optionality to only do that for some artifacts. I feel like you could do cool and convenient things in the platform if you sort of preserved the URIs in the metadata so that you could hydrate the offline assets later instead of doing it up front if you wanted to.
Yeah,
Yeah.
that
Kind
was,
Sorry, go ahead.
I guess
So I
that
think-
was like along the lines I was thinking about was if I had an online, well, I guess we're calling it online, but maybe that's also the wrong terminology, but like non-hydrated build pack, that does the build pack need to then build all the logic to hydrate itself, or is the expectation that this would be handled either by the platform or somewhere else, so that the build pack could always assume that that depth directory is always filled?
Yeah, so as things stand right now, they're completely separate artifacts. There's like a little piece in this alternative section around like forcing you to have these like URIs and forcing these like the labels on each image to actually have references to where their offline artifacts would end up. So if they're present on the registry, they can just get used. That's not like, that might not be like a tight enough tie though, because those things are then like subject to just getting deleted. And because there's no like real ties other than this label metadata, your online or your offline builds could then just get switched back to being online builds.
Sorry, go ahead.
I was going to I want to make sure that I completely understand the way that the current RFC is spelled out. The platform or lifecycle don't have to do anything, right? Because it would just be very specific locations within the builder itself or the packages that then would have the additional dependencies, and then the build pack is looking at those. So let's say, for instance, pack or lifecycle don't have to care about anything in relation to the information, the metadata, and whether or not those layers should be hydrated. Is that right?
So I think it would actually have to do some additional behavior, because these would like suddenly be layers that didn't exist in the build pack, the like online build package that you're using. They're just sitting on like the registry. So I'm not exactly sure how pack would navigate that, but I'm gonna assume that's different than just having everything in a build pack and basically treating all these new dependency layers as the same exact things as build pack layers. We can just unzip them, they end up.
Okay, so then pack or the platform would read the information in the label and say, okay, this isn't there, so I'm going to go pull it from this location and place it in that area. Is that right?
That's an option. That's not something I've outlined here.
Okay.
You could think of it like if your build package has dependency layers in it, you use your build package to do a builder. The dependency layers flow into the builder, right, and hydrate that builder's cache so that when builds are done on that builder, those dependencies are present and the build packs can use them. And then like in a platform like KPack, you could decide when you're building your builder what cache dependencies to include in the builder, and kind of control the performance characteristics. Only include the latest patch versions of things if you wanted to. You could have more configuration over that in the process of builder building.
So I think one of the things that might be in line with what other people have been asking about, and might be overzealous, but I think overall might be necessary, is if we look at the depths diff IDs, right now they're just arrays, where I think it would be helpful to have the entire metadata. So almost like a map in a case where we know what the ID and version of that thing is, so that we could do more effective lookups if we needed to. And then I think alongside with that, we could add the existing data that is in the build pack or the offline TOML.
Okay. Yeah, I mean, that's definitely possible. One of the things I ran into like earlier on in this process was having a ton of metadata on the outside of this image label, but then suddenly you lose access to that. And so my initial kind of like way to circumnavigate that would just kind of be, well, we have this like additional TOML file that's sitting around. Oops. it doesn't really have a use right now.
I think the problem with the TOML file is that it's not statically inspectable, right? Like we can't look it up. We'd have to crack it open to inspect it.
It'd be easy to take the contents of that file and stamp them on the label.
Right.
You know, also just so it's easier to inspect from the outside. I think that can make a lot of sense.
I feel like a lot of the builder magic you're talking about, Stephen, is really like the magic of subtraction. It's like imagining that there's a world where everything is packaged offline, and then when you create a builder, you can sort of opt out of things, which I do think has a lot of value, because you might want a smaller builder image that doesn't have a bunch of dependencies you don't need. But I'm wondering if there's a way we can frame it so that instead you can have a bunch of online, it also works with a bunch of online artifacts, and then you can hydrate specific things. I feel like would be very convenient.
One thing I was thinking about with this model along those lines is a few times it's come up that this means that the digest of a build pack is the invariant digest of a build pack ID inversion is the layer SHA, right? And that works pretty well. So you can, a build package could be really small or really big, packaged with a lot of things or not, and you still have the same digest for the build package. But when you're talking about meta build packs, it might be useful not to have to track all of the sub build pack SHAs together to guarantee that invariance. And so, I was a big fan of letting the build pack digest vary for different build pack IDs and versions depending on how it's packaged. So the build package digest vary. I could see an argument for taking the cache dependencies out of it, keeping that invariant, and that would also let you inject them later in the process.
Yeah, that's a point I was thinking about the other day. Like, what if when you packaged an offline build pack, instead of getting one image, you got two images, but where one of them contains a reference to the other one?
You could also, because we did want to kill package TOML eventually when you have a registry, you could also see the packaging of the dependencies even being a separate thing from packaging the build pack. Like even more decoupled from that.
Or just have one image that's just basically a blob store, so we can just abuse Docker Hub and then say whenever I'm using Paketo build packs, go fetch my dependencies from this image. Just something to think about. Sorry.
Yeah,
Don't mean to make it more complicated, Dan.
No, it's fine.
I'm just trying to co-op the thing that you want to get done for your purposes to solve my purposes, which is
Yeah, I was gonna say I lost you guys
offline builders from an online builder without repackaging everything.
I don't think that's actually a very large change. I mean, it seems like it's because the artifacts change a lot. It seems like it's different from what's proposed, but everything here about the paths and how you construct those images stayed the same. It just takes the in the build package thing and pulls it out into a different image for a little bit more decoupling. And then there are definitely some benefits there. I'm not fully convinced this is the direction we should go, but I'm becoming more convinced as sort of people point out the problems with putting them inside of the build package.
Okay, yeah. Well, I can definitely make some changes in that direction.
Maybe we can meet up. I'll do kind of a one-off SIG meeting thing and chat about what some of those changes could look like. Emily, if you'd be interested too, because I know you have ideas around this. Awesome.
Yeah, could you post it somewhere or invite me as well? I'm interested.
That sounds great. I know, Dan, you're going to kind of dig into what it looks like to implement this at some point too, so we should probably do that kind of soon. Awesome. I actually got to drop off a couple minutes early. Thanks, everybody.
See, Stephen. I know on the kind of Salesforce Roku side, we've been talking about wanting to be able to vendor assets or dependencies. Do you feel like this fits in line with kind of solving that use case as well?
Yeah, I mean, I feel like that this is like the exact solution for that. Like, yeah, because I think we are like doing that, or we're trying to figure out ways to do the same thing. And This is like the inevitable problem we run up into, is like managing a ton of different build packs. They're all almost exactly the same.
Yeah, I guess maybe it's some of the terminology that throws me off, of just like, it's not really about making, at least in this use case, like offline or online. It's like, we literally just want to vendor, and we will always vendor this dependency in. But it seems like this would solve that. I just would always package it, and that's just how I publish it.
Say offline. By that we just mean we vendored all the dependencies. But I imagine, you know, you could vendor some subset of them, and it's not really offline. It's just vendored.
Yeah.
Because they could still reach out to the internet sometimes. There's nothing that stops you from doing that now. Like, we do that now, but it's just you running.
It's very manual, right?
Registries, storage, and stuff like that.
Yeah, I just wondering, like, can I, similar, I guess, to Emily's statement, can I piggyback off of other stuff to solve those problems for myself?
And then the really cool thing here, if I'm not mistaken, is we could tie it into some caching improvements, right? When certain dependencies are shared across different applications, these would be very specific to identifiers that are globally unique, in which we could cache things like the JDK from not having to be downloaded multiple times.
Yeah, I know for us, like, there's even simple stuff like YJ or something for the bash build packs that we have. Like, it seems like every bash build pack uses it because they need to do TOML stuff, right? And being able to have a globally unique thing that is only packaged one time, no matter how many times every single build pack packages it, would be nice.
Yeah, okay. Well, I'll definitely take like additional dig into like solutions around hydrating layers of dependencies that are common across multiple build packs. Yeah.
What changes would you make versus what you have today on that? Or like what it's like in this RC, or what are you thinking along those lines?
So if we're gonna allow for there to be any sort of hydration, there need to be like some kind of like clause around always producing the metadata you need to find offline dependencies, right? Or these dependencies that exist. And then there'd be another piece, which I think Javier brought up, which is, okay, how does Pack actually reach out and grab this if it's not just sitting in the build package? So,
right, so an example of how a platform would then retrieve the information, tie it all together into having it in the build process.
Gotcha.
And so when we talk about making it required here in this section, right, I'm assuming it's talking about required only for the things that you opt in to be vendored or vendorable. Is that right? Cool.
I think we're at time. Is that right? Thanks for putting all that together. Very excited for this feature.
Okay. Thanks for the feedback.
All right. See y'all.